All right, example 5. This one should be a little bit easier for everybody because you're using, if you look at it, you have like trig identities happening kind of like at the beginning of the problem, so you can actually work on it, Pythagorean identities. So you have a tangent squared x plus 1, you have a cosine squared x minus 1. So you have trig identities going on there. And again, that's the most complicated side. There's no fractions going on. So the first thing you might try to think is like, maybe I should multiply that out. I would say, okay, no, don't multiply it out yet. Look at what's going on and see if there are any trig identities happening. So this one, there's no fractions happening. There's really no factoring that needs to happen because they're kind of already factored down, or they're already like broken apart, so you don't need to factor it. You don't need to find a common denominator for that to add fractions. You don't have to worry about doing really any of that other part. And here, you don't even need to really deal with sine and cosine yet, because from the get-go, you have trig identities happening. Because tangent squared x plus 1, that's a trig identity. So what is that trig? What is that equal to? Tangent squared plus 1. What is it equal to? What is it equal to? What is it equal to? It's secant, right? Secant squared. So tan squared x plus 1 equals secant squared x. Remember that? Okay. And then the other one, remember our sine squared. Let me change this to sine squared plus cosine squared equals 1. And then here we can manipulate things around. So if we move that 1 over here, we will have the sine different color. Let me do a different color so everything doesn't look the same. We can move that 1 over so we get this. And then we can move the sine over so we can get the cosine squared minus 1. Again, manipulation is very important, but you have to know your trig identities to know how to manipulate them correctly. It's okay. Running low, but we're going to make it through. And so here, sorry, it should be negative sine squared, because we subtract sine squared from both sides. So here, we have a negative sine squared x, and we're trying to see if that would equal a negative tangent squared x. All right, now, with this, the biggest part that we're dealing with now is we have a sine squared x, we have a secant squared x, and we have to get to tangent squared x. So with that, we already know that our trig identity here, the tangent squared x plus 1 equals secant squared x. We don't need to go backwards from secant squared to get us back to a tangent of some sort, because then we're multiplying and it won't work out. So that one, we have to try to figure out, okay, what's another trig identity that has that tangent squared, that tangent in it, that we can work with. And because we also know tangent is, let's say x, is sine x, so for cosine x, which is our trig identity, or which our quotient identity. So with that, can we make this happen so that it deals with sine over cosine? And actually we can, because remember secant, same thing as saying 1 over cosine, and we square both of them, and it gives us what we need. So here, if we make this 1 over cosine squared x, and we keep this as a negative sine squared x, we can multiply those two and get an answer that hopefully should be a negative tangent squared x. Right? Right. So here, if you multiply straight across, because it's the same thing as saying over 1, multiply straight across, 1 times negative sine squared x is just negative sine squared x. Cosine squared times 1 is cosine squared x. And then again, we know sine over cosine is tangent, and we just leave the negative in front. So we just took this part here, we went through our identity over here. Oh, let's erase that a little bit. Back it up, back it up, back up, back up. So we did here, which took us here. And then we were able to move that over here. And then the negative sign was there. And that gives us the negative tangent squared that we need. Bam. And again here, you're going to have to just do trial and error. I was able to see it originally because I've done this a couple of times, a lot of times already. I've done this for back when I was in high school. I did this in college. So it's one of those things of I've taught it like years ago. And so now it's just coming back of using the rules to help us to understand and using what you remember from your regular classes, from fractions with multiplying binomials or foiling or whatever it is. All of that comes back to play here. So that's how I'm able just to go through it and be able to get it right. So just keep working, keep trying.